Hey, this is Math 6, Unit 2, Lesson 9, talking today about constant speed. And so we're going to use ratios to work with how fast things are moving at a constant rate, meaning it's going to start a motion, it's going to be going at the same rate or the same amount of time, never changing its speed. So that's going to be a constant rate. Okay? Now, first of all, we'll have a little number talk here, and it says find the quotient mentally. Quotient's when we're dividing things here. So looking at 30 divided by 10, if we're dividing anything by 10, it's just going to be moving the decimal place over one spot. So it becomes just simply 3 or 3.0. If I divide 34 by 10, it becomes 33.4. Again, dividing 3.4 by 10, moving the decimal one place to the left, so I end up with 0.34. Alright, now if I move the decimal one place to the left when I'm dividing by 10, if I divide by 100, I'll move it 2 places. So I have 34 and go 1, 2, end up at 0.34. So just finding some quotients mentally, how to move things around when we're dividing by 10 or 100. It'll come in handy later on. Now kids and teachers, I'm sorry about the next activity, but number 2 actually wants you to do an experiment that's going to require you and some friends to do some walking. Okay, and I'm not going to walk, and you're not going to watch a video of me walking, because that just would be weird. So, your teacher will set up a straight path with a 1 meter warm-up zone, that's here, 1 meter warm-up zone, and a 10 meter measuring zone. Follow the following instructions to collect the data. So what we're going to have basically is we're going to have like a starting line here where you're going to kind of get warmed up and get your pace going, and then you'll start to walk from here to here, while your partner is going to actually use a stopwatch or whatever, and time how long it takes for you to walk around, to walk from there to there at a constant speed, because our topic today is about a constant speed. It says A, the person with a stopwatch, the timer, stands at the finish line. So one of you would stand over here with your stopwatch. That's a giant stopwatch, but there you are, happily having a good time. Okay, the person being timed, the mover, stands at the warm-up line, so you're over here. Okay. In the first round, the mover starts moving at a slow, steady speed along the path. So first we're going to go slow and steady the first time there. Okay. And when you, the mover, get to the start line, you're going to yell start, so this guy can start his stopwatch, and then they'll stop it once you get there. The key thing is the mover keeps moving steadily along the path, and when you reach the finish line, the timer stops the stopwatch. And then we're going to record it on the table. Round to the nearest second, so get it kind of close. So if it's 5.2 seconds, just call it 5. That's fine. On the second round, the mover follows the same instructions, but this time moves at a quick and steady pace. So you're going to do one at quick and slow and steady, and another at a quick and steady. Just to have a couple different speeds that you're going at, a couple different rates that you're going at, and someone's going to record you each time. Now you can use this chart right here to make sure everyone in your group goes a couple times, once at a slow and once at a steady pace, and once at a so once is slow and steady and once quick there, so that you can have your time in seconds for each one of those, and that becomes your rate. Once you've done that, then we're going to collect that data and we're going to analyze it and talk about it as a class. Again, this is something I'm going to skip through here, and you can do it on your own or with your class, however that works out. If you're working from home by yourself, you could try it yourself if you wanted to, and get out your watch or your, the stopwatch on your phone and just measure and see what it's like. Okay? Then you're going to use this to then say, well, I went 10 meters in, maybe you went in 5 seconds when you went slowly, and when you went fast, you did 10 meters in 2 seconds. I don't know, just making that up there. Okay? The idea is to then use those numbers to estimate the distance you traveled in 1 second when moving slowly. Okay? So let's pretend that I did go 10 meters in 5 seconds when I went slowly. The question then is, if I go 10 meters in 5 seconds when going slowly, what is my rate that I'm traveling at? How many meters am I doing in 1 second? That's the idea. That will tell me what my actual constant speed is going to be. So if I happen to go in 5 seconds to 10 meters, I could then say it's 10 divided by 5 is 2. So I could say that going slowly, I was moving at 2 meters per second. Okay, just as an idea. If I wanted to do the quickly one, I could also look at this rate, which is right there, and say I'm going 10 meters in 2 seconds. So how many meters am I going in 1 second? Well, to go from there to there is dividing by 2. So 10 divided by 2, or 10 divided by 2, is going to be 5. So in this case here, my speedy one was 5 meters per second. So what I've created here, again with this per second idea, is a rate, but we're talking about this being a constant speed. So our constant speed is the rate that we are traveling in. Alright, and that's what we're looking at here. So let's look at activity number 3. Moving for 10 seconds. It says Lynn and Diego both ran for 10 seconds, each at their own constant speed. So they're both going, Lynn and Diego, for 10 seconds. They're traveling. Now Lynn ran 40 meters and Diego ran 55 meters. So what we know is this so far. We know that for Lynn, with one N, sorry, that Lynn was going at a rate in which she went 40 meters in 10 seconds. We also know that Diego went 55 meters in 10 seconds. So this is just the given facts that we know. Who was moving faster, and explain your reasoning. Now, to do this here, you want to look at both pieces of data. Lynn went 40 meters and Diego went 55 meters. But they did that in what? The same amount of time. So time was the thing that didn't change for either one of them. But in 10 seconds, Diego went 55 and Lynn only went 40. So in terms of who went faster, we would have to say that Diego was traveling faster because he was able to go 55 meters in the same amount of time that Lynn went 40. Okay? In order to show this more mathematically, we could talk about how far they went per second as a 1 second kind of idea. Okay? So, if you had meters and you had seconds, right? And here's Lynn. Lynn went 40 meters in 10 seconds. The question would be, how many meters did she go in 1 second? To solve that there, if we're going this direction, we're multiplying by the reciprocal, which is times 1/10, or dividing by 10. Well, what is 40 divided by 10? 40 divided by 10 for Lynn is going to be, in this case here, 4 meters per second. That was the rate she was going in. Now, for Diego, Diego's here. Here's Diego, his meters and his seconds. Diego went 55 meters in 10 seconds. So if we're going to go how many meters in 1 second, we're going to divide by 10. And back to that mental math work we had earlier, that becomes 5.5. So Diego is 5.5 meters per second. So he's going at a faster rate than Lynn is going there. Again, the double number line shows it, right? And you can see the difference there. And we can also look at the math for the per second rate to see what's going on there. Okay, I'm going to go ahead and let's see. Okay, use your data from the previous activity to find how far you could travel in 10 seconds at your quicker speed. So if I went back to what I had before, I said my quicker speed was 5 meters per second is what I wrote down before. This was just my thing here. So my quicker speed was 5 meters per second. So 5 meters per second, 5 meters per second. So if I went 5 meters per second for 10 seconds, how far would I go? I would go 50 meters if I kept that same constant rate. It says that Han ran 100 meters in 20 seconds at a constant speed. Is it faster, slower, or the same as Lynn and Diego's? Okay, well, let's take a look. We have 100 meters and we have 20 seconds. The best thing to do would be to get this in terms of a unit rate of what that constant speed is going to be. So 100 divided by 20 to get this down to a 1 per 1 second, is the idea. I could look and say 100 divided by 20, I could knock the zeros off there because they both are there, and I have 10 divided by 2, which is going to be simply 5 meters. So Han is going at 5 meters per second. Lynn, we said, was 4 meters per second. Okay, and then Diego was 5.5 meters per second. So he's going faster than Lynn, but slower than Diego. Compared to me, at my constant speed, I guess if you looked at my fast one, he's going the same because I said 5 meters per second for me. Okay? That's the idea. The Are You Ready for More questions? A great little question here, if you have time. It says Lynn and Diego want to run a race in which they both will finish when the timer reads 30 seconds. Who should get a head start and how long should it be? So in this case here, we're thinking about the fact that they're going to run and they want to they're going to run for 30 seconds, but they're going to run a race and they're going to go for 30 seconds, but they want to finish at the same time. Okay? So Lynn, our friend Lynn here, she runs at a rate of 4 meters a second. Now if she ran 4 meters per second for 30 seconds, because that's how far she's running, how far will she get? 4 meters for 30 seconds means she can go 120 meters in that time. For Diego, he's going 5.5 meters every second, and if he does that for 30 seconds in the same time, he's going to go 165 meters. Now if they want to finish at the same time and finish when at the racing same spot, we have to give Lynn a head start. Otherwise, she's not going to win, right? Diego's gonna beat her no matter what, and finish early. So to make it the same, if we give Lynn an additional head start of 45 meters, okay, a 45 meter head start, then her 120 plus the 45 meters, okay, is going to make sure that she ends up running an additional 40, well, it would be like the distance of 45. She'll get 165 and she'll match Diego and they'll be in good shape. So at the end of 30 seconds, they would have gone the same distance, supposedly, because she started 45 meters earlier, but not really. Anyways, not a big deal. Summary, real quick, I'll wrap it up here. Suppose a train traveled 100 meters in 5 seconds at a constant speed. To find its speed in meters per second, we can create a double number line. Again, when we're talking about speed, we're talking about a constant speed. It can measured in meters per second, miles per minute, things of that nature there. And we could use a double number line to help us figure that out there. So once we know a speed in the meters per second kind of category here, we can use that information to help us compare rates of lots of other things. So, all right, that's it for today so far. We're going to pause there and then take a moment for homework and come back in a second. All right, Han ran 10 meters in 2.7 seconds. Priya ran 10 meters in 2.4 seconds. Who ran faster? Okay, so they got the same distance, 10 meters, each was 10 meters, and Priya did it in 2.4 and Han ran it in 2.7. So Priya seemed to run it faster, and that's because 2.4 is less time than 2.7. In a race, the smaller time is the winner, okay? At this rate, how long would it take each person to run 50 meters? Well, to find out how long each person does 50 meters, you take their rate, 2.7, and we multiply it by 5. We multiply it by 50. Okay, actually we multiply by 5, sorry, not 50, because that's 10 meters there, so 50 is 5 more. So we would say 35, 10, and 3, so we have 13.5 for Han, and for Priya, she's doing 2.4 in 10 meters. For 50 meters, we end up with 12. All right, number 2. A scooter travels 30 feet in 2 seconds at a constant speed. Nice. What is the speed of a scooter in feet per second? So we want to know, here's the 1, how many meters does it do in 1 second? So here we go. To go from 2 to 1, we are multiplying by the reciprocal. That's 2 times a half, or 2 divided by 2, however you want to look at that. And whatever I do to the top or the bottom, I'm going to do the top. So let's do 30 times the reciprocal, or 30 divided by 2. Either way, you end up with 15. So the speed of the scooter in feet per second is 15 feet per second. All right. Complete the double number line to show the distances the scooter travels after 1, 3, 4, and 5. Well, we did the 1 already. So here's 3, and here's 4, and here's 5. All right, so I can think of it this way. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 seconds becomes 45. 15 times 4 seconds gets me to 60. And 15 times 5 seconds gets me to 75 feet. All right, so the skateboard travels 55 feet in 4 seconds. Is a skateboard going faster, slower, or the same as a scooter? Well, let's take a look here. It's saying that it goes 55 feet in 4 seconds. When we look at our thing here, we know that we can go 60 feet in 4 seconds. These aren't equivalent ratios, they're different numbers. So is this rate here faster or slower or the same? Well, in the same amount of time, this one seems to be going further. Time's the same, and this guy got to 60 feet, that got to 55. So this one's going faster than that one, which means the skateboard is going slower, because that's 55 in 4, and the scooter's going 60 in 4. All right, number 3. A cargo ship travels 150 nautical miles in 6 hours at a constant speed. 150 in 6 hours, constant speed. How far did the cargo ship travel in 1 hour? So here's our 1 hour. And the question is what goes there? And from what we've seen, again, to go from 6 to 1, we are dividing by 6. So if I do 150 divided by 6, 6 goes into 15 2 times for 12. Bring down a 3 and 30. Goes in there 5 for 25 nautical miles. So how far did it go? It went 25 nautical miles. It's going the same constant speed. Alright, next page. Page number 4. A recipe for pasta dough says use 150 grams of flour per large egg. So what are we saying? We're using 150 flour per 1 egg. Great. How much flour is needed if 6 large eggs are used? Okay, so we're saying here is the equivalent ratio. How much flour is needed if I'm going to have 6 eggs? So to go from 1 to 6, I'm going to multiply by 6. So 150 times 6, 150 times 6 will equal 900 grams of flour. Going the other way, how many eggs are needed if 450 grams of flour are used? So I take my 150 flour times 1 egg, right? That's what I know so far as my rate. And I'm going to say, well, if I'm doing 450 grams of flour, how many eggs? To go from 150 to 350, that becomes times 3. So 1 times 3 is 3. We would say 3 eggs. Could you draw it out in a double number line? You certainly could, right? You could draw it out like this, and we could say we have 150 to 1. Okay. And then if we went out 2 and 3 and continue to count, we have 150, double it is 300, times 3 is 450, and that's where we get that answer right there. Number 2. A grocery store is having a sale on frozen vegetables. 4 bags are being sold for $11.96 at this rate. What's the cost of 1 bag? And then 9 bags. All right, so right now our cost is $11.96 for 4 bags. That's what we know. So what is that rate in terms of being at 1 bag? So if we're doing 1 bag, it's the price per 1 bag. When I get this price per 1 bag, or that unit right there, I just do 11.96 divided by 4. So 11.96 divided by 4. 4 goes into 11 2 times for 8. Put the decimal point up there right away. And subtract, and we have 39. 4 goes into 39 9 times for 36. We bring the 6 down there, and 9. So my unit rate for 1 is $2.99 per bag. If I then have 9 bags, then I'm going to multiply that by 9. We have 8 81. 81 plus 8 is 89. Have an 8 there. 18 plus 8 is 26. So we'd say $26.91. Number 6. A pet owner has 5 cats. Each cat has 2 ears and 4 paws. That's encouraging. Complete the double number line to show the number of ears and paws for 1, 2, 3, 4, 5 cats. Okay, I'm going to add another line up here for just the number of cats, just so I can keep track here a little bit better. Okay, and so we have 1, 2, 3, 4, 5 cats. 1, 2, 3, 4, 5 cats. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So number of ears here, and complete the number line. So if I have 1 cat, I'm going to have 2 ears and 4 paws. If I have 2 cats, then I'd have 2, 4, 6, 8, and 10. And the legs are going to count by 4s. 4, 8, 12, 16, and 20. So let's take a look here. If there are 3 cats in the room, here's 3. What is the ratio of ears to paws? So ears is 6 to paws 12. So 6 to 12. Make sure you get the order right. Ears to paws. 4 cats in the room. Here's 4. Ratio paws to ears. So we're going to say 16 to 8. 16 to 8. If all 5 cats in the room, how many more paws than ears? Okay, so here are 5 cats. How many more paws than ears is 20 minus 10. There are 10 more paws than there are ears. That is super exciting news. All right, each of these is a pair of equivalent ratios. For each pair, explain why and draw a representation, or explain why or draw a representation that shows why. All right, so here we go. We have 5 to 1. So 5 to 1 is equivalent to 15 to 3, because if I multiply this by 3, I multiply that by 3 as well, and they do equal up, and we're okay. If you wanted to draw a tape diagram like so, you could, and you could do 5 here and 1 there, and then you could do 15 and you could do 3. You could even do a 2 and a 10 to make the whole tape diagram, and that would be just fine. So a couple different ways you could draw that or write that out there. Okay, if you want to draw a picture, right, you could do a 5, 1, 2, 3, 4, 5 to 1, right? So that is 5 squares to 1 triangle, and then I could do another picture of 15 and 3 to show it's the same. That'd be a lot of drawing though. Okay, let's take a look at the next one there. Again, another equivalent ratio. This one's a little different. We have 25 to 2, 25 to 2, and then we have 25 to 5, and then 10 to 2. When you look at this, there's not a clear move over, make them work. I can't make that I know it's equivalent because it told me it was, but I can't prove it with just a quick number thing here. But I could turn this into a unit rate. Instead of 10 to 2, that can become 5 to 1. And when we look at 5 to 1, now I know that 5 times 5 is 25, and 1 times 5 is also 5, right? So we're in good shape there. So I can just convert this down or reduce it down to a unit rate instead of 10 to 2, 5 to 1, and then show how they're equivalent. And our last one here, we have 198 over 1,287. It says it's equivalent to 2 to 13. Okay, so I have to think about 2 times what number can get me to 198. That's a lot. If I'd go this way, I could do 198. Let's divide it by 2, and we end up with 99. So 2 times 99 is 198. Is 13 times 99 equal to 1287? Let's see. We have 7, 2, 9, 10, 11, 0. We have 27, 2, and we have 9, 10, 11. We have 7, 8, 2, and 1. That seems to match, and so we can prove that that is actually right. This is also multiplying by 99. All right, that's it for today. Have a great day, and we'll see you next time.